For 60 years, the smartest planetary scientists on Earth were trapped in two camps. No middle ground, no compromise. Camp 1 said Jupiter had no core at all, gas all the way down, a failed star with nothing solid at its center. Camp 2 said Jupiter had a compact, iron-rich nucleus, the kind of foundation every textbook said a gas giant needed to form. Both camps were certain, both had airtight equations, both had models built into every curriculum on every continent. Both were wrong. NASA sent a spacecraft called Juno to settle the argument. Juno didn't pick a winner, it dissolved the question entirely. Jupiter's core exists, but it has no edge, no boundary, no surface you could point at. It's a region spanning roughly 70,000 kilometers across, where heavy elements dissolve into hydrogen like ink bleeding through water. And when scientists tried to explain how it formed, every single model failed. Camp 1 had a clean, almost beautiful story. Jupiter formed like a star that gave up halfway. A massive cloud of hydrogen and helium collapsed under its own gravity. No solid center, no seed. Fall beneath the cloud tops in this model and you'd never hit anything, just increasing pressure until you became part of the hydrogen itself. 400 years of telescope observations, mathematics, coherence. This was the standard. Camp 2 had an equally clean story. In the cold outer solar nebula, heavy elements condensed first. Rock, iron, ice. They accumulated into a solid nucleus, 5 to 20 times Earth's mass. Once that nucleus grew heavy enough, its gravity caught the surrounding hydrogen and helium. Layer by layer, a gas giant was built, always anchored to something solid. Core accretion theory. It explained Jupiter, it explained Saturn, it explained every exoplanet anyone could measure. Two airtight frameworks, both taught in universities worldwide, and both waiting for Juno to prove them right. Juno doesn't photograph Jupiter's interior. No camera can. What Juno does is listen, specifically to how Jupiter's gravity pulls on it. The spacecraft swings within 4,200 kilometers of the cloud tops at over 200,000 kilometers per hour. And Jupiter's gravity has a continuous, silent conversation with the spacecraft. Every variation in mass distribution inside the planet creates a gravitational tug, differences measured in fractions of a millimeter per second. Juno detects all of it via Doppler radio shift. The spacecraft transmits toward Earth. Jupiter's gravity alters that signal's frequency by an amount so small it's equivalent to measuring the width of a human hair from across an entire room. Orbit after orbit, pass after pass, Juno builds a mass map approximately 100 times more precise than any previous Jupiter mission ever achieved. And what that map revealed, no one predicted. There is a core, that much is certain, but it has no defined edge. The heavy elements at Jupiter's center don't end at a clean boundary. They thin out gradually over a region spanning roughly 70,000 kilometers across, wider than 5.5 Earths stacked side by side. And there is no surface. Nothing you could point at and say, here, this is where the interior ends and the hydrogen envelope begins. Core accretion theory, the framework that built planetary science's understanding of every gas giant, demands a solid, compact nucleus, a clear foundation gravity can build on top of. What Juno found is a gradient, a slow dissolve, a center that does not behave like a center. 3 doors open simultaneously. Either Jupiter formed this way, which breaks everything we thought we knew about planet formation, or something catastrophic destroyed the solid core after formation. Or our physics at these pressures is fundamentally incomplete. All 3 doors are still open. The collision theory felt tractable. A protoplanet, maybe 10 times the mass of Earth, slammed into a young Jupiter at high velocity. The impact shattered the solid core. Heavy debris scattered upward into the hydrogen envelope. Billions of years later, Juno detects the aftermath, a diffuse, boundaryless remnant. It was elegant, it was violent, and it was the leading explanation for nearly a decade. But there was a problem, and it's a physics problem. In August 2025, a team at Durham University published the most comprehensive test of the impact hypothesis ever attempted. Hundreds of supercomputer simulations, smoothed particle hydrodynamics models tracking exactly what happens when a massive object hits a young Jupiter at various angles, velocities, and masses. The results appeared in monthly notices of the Royal Astronomical Society. They were clear. They were devastating. None of the simulations produced a stable dilute core, not a single one. The impact scattered the debris, but the heavy material always sank back. Like sediment settling to the bottom of a disturbed glass of water, it reformed a sharp boundary every time, without exception. The physics is uncompromising. Heavy elements sink. Sharp boundaries reform. The giant impact hypothesis is dead, which leaves something harder to accept. The answer came from Saturn, specifically from Saturn's rings. Saturn's rings are not static. They ripple, enormous spiral waves driven by vibrations deep inside the planet itself. When Cassini orbited Saturn, it captured those ripples in extraordinary detail. In 2021, a Caltech team led by Christopher Mankiewicz asked a question nobody had thought to ask before. What if Saturn's rings are the planet communicating something about its own interior? They combined the ring wave data with Cassini's gravitational measurements. The analysis, published in Nature Astronomy, delivered one specific, unavoidable conclusion. Saturn's deep interior is not convecting. Something is holding heavy elements toward the center, letting them thin out gradually. No clean boundary, spanning approximately 60% of Saturn's radius, containing roughly 17 Earth masses of heavy elements. Saturn has a diffuse core too. Two gas giants, different distances from the Sun. Different sizes, different compositions, the same anomalous internal structure. Two independent collision impacts producing identical outcomes. The probability is negligible. This is how gas giants actually form. Before we continue, if you want to understand how the universe actually works, not how textbooks from 10 years ago said it should, subscribe now. Every week, Cosmo Cypher decodes one cosmic mystery that science just figured out. Hit subscribe. Let's continue. Look at what this actually overturns. More than 5,500 confirmed exoplanets have been catalogued and classified using frameworks built on the assumption of solid cores. Cooling timelines, interior pressure profiles, habitability zone calculations, all derived from models that assumed Jupiter and Saturn, the only two gas giants close enough to study with precision, had structures consistent with the theory. They don't. The thousands of gas giants beyond this solar system have been labeled, classified, and taught to students worldwide, using a framework that may not describe what is actually inside any of them. We built a catalogue of alien worlds on a foundation that doesn't hold. There's one more layer, and it makes everything stranger. Jupiter's magnetic field. The magnetosphere stretches nearly 1 billion kilometers behind the planet, far enough to reach Saturn's orbit. It's generated where pressure exceeds 4 million times Earth's atmospheric pressure. At these pressures, hydrogen atoms collapse. Electrons break free and flow independently, and hydrogen transforms into an electrically conductive metal. A planet-spanning ocean, but not of water, of liquid metallic hydrogen. The resulting magnetic field is 20,000 times stronger than Earth's, and it has features nobody can explain. Stronger in the north than in the south. Intense localized concentrations at specific latitudes. Two magnetic south poles, a configuration that should be impossible if the dynamo were uniform. Scientists hoped the diffuse core would explain these anomalies. It doesn't. It makes them harder to explain. Unknown mechanism, no consensus. Active research. At both poles, continuous ultraviolet auroras burn without pause, each larger than Earth's entire surface, releasing more energy daily than all of Earth's auroras combined in a year. Hubble captures them in ultraviolet. We cannot see them with the naked eye. The field powering them remains unexplained, beautiful, relentless, unexplained. Here is the precise inventory. We know Jupiter has a diffuse interior spanning roughly half its radius. We know Saturn has the same structure, confirmed independently through ring seismology. We know the giant impact model was computationally tested across hundreds of simulations, and it failed every single time. We know our formation models require a solid foundation that neither gas giant possesses. What we don't know, whether this structure is stable or slowly evolving, whether the formation models need modification or complete replacement, whether any of the 5,500 exoplanets in our catalogues are structured the way we've been assuming, whether the magnetic anomalies are a consequence of the diffuse interior or a completely separate problem. Juno was sent to settle a 60-year argument. It settled nothing. It dissolved the question entirely. Jupiter is still out there, interior undefined, boundaries absent, magnetic field operating by unknown rules, auroras burning at both poles without pause. The largest planet we can examine in detail, and its center remains one of the most consequential unsolved problems in planetary science.